Today we are going to discuss one of the important data structure, linear data structure, that is the queue. What is the queue and how we can implement the queue, different applications of the queue, and then we will see different types of queue. Hello everyone, this is Sharda from GoEduHub Technologies and I would like to welcome you for this 10th class of this DSA with Python course. Am I audible? Can you please confirm me in the chat window so that we can go ahead? And you guys can see there in the description of this video, there is a link of article that I'm going to cover what is the queue. Okay. As we already studied 3 linear data structures, one is the array and linked list and a stack. We have covered all 3, array, linked list and stack, and today we are going to cover one more linear data structure, that is the queue. Queue is basically, it is just like you can relate this with your day-to-day life, like when we are going to book a ticket, like you are going to a cinema, a theater, and you will standing in a queue, and how the people will respond you, like first come first serve. Okay, so basically what happens here, it is just like a queue at a railway station counter. The person who is coming first will be served first, and it is a queue like you are standing over the bus stops or railway, or it is just like a single one-way road where the vehicles enter first and exit first. Okay, so basically it is kind of thing, whoever is coming first will get the things first. Okay, when multiple users, like you are using a common printer in your college and multiple people are connected to the printer and they want to print something, so everybody is giving some instruction. What happens, how printer will decide, it will check the priority, whoever request is coming first will be served first. Okay, so it is just like that. And simple data structure, here we have 2 things, like this is a diagram you can see, and we have certain elements, and this element first inserted, this is the first person, then second, third, fourth, fifth and sixth. Okay, and then this first one who enters the first will exit the first, and the operation which we call exit is called the DQ. Okay, and this node is called the front. So we are doing the DQ operation from the front. The person who is standing near to window is going to receive the ticket first. Okay, and last person who is coming at last to the window will be served last, and other person can be added at the end. So end point here we call rear. Okay, and new elements ready to enter in the queue, and this process is called Enqueue. So there is the new term front, rear, DQ and Enqueue. So front is the person who is coming in the start and from where we are going to serve. So the person you are serving, you are going to be delete, or you are going to be remove, like this person is served. So this process is called DQ, and we are adding some more people or some more items, then we can say this is Enqueue, and end where we are working is called the rear. Okay, so now come to the technical definition. A queue is a linear list of elements in which deletion can take place only one end. Okay, deletion is at front end and insertion can take place only the other end, called the rear. So at the rear we will do the insertion, at the front we will do the deletion. Okay, and similarly queue is non-primitive data structure. It is an abstract data structure. So whatever this abstract data structure, what we have in the abstract data structure, we have certain operations. We need to do those operations in the abstract data structure we don't know how to do. So basically, operations, what operation we are going to do in the queue? Operations on the queue. Basic operations, I can tell you, one is the enqueue that we already know. Enqueue operation is used to add the element at the rear end. So we are going to add more elements, you can say simply. And if your queue is full, then you can say it is overflow condition. Okay? And another thing is dequeue. Dequeue is basically this deletes the element, you can say removes the element from the front end. So this operation also you know. Okay? And it is kind of, you can assume queue is like if you are viewing some stock exchange sites. Okay, so like Yahoo stock exchange Yahoo stock size, if you see online, what happens here? They are taking the data from some stock size servers like New York Stock Service. Okay, they are picking the data from some sites and showing to you what's the value of now stocks. What happens here? They are taking the data in a queue, in the form of queue, like whatever NSE server is producing, and this side which is showing the data will pick the data in the form of queue only. So you can say it is like of consumer and supplier problem, where one common supplier is supplying to the multiple consumers, and the consumer who is coming first will be served first. Okay? So DQ you know, NQ you know, peak you know. Peak what is? Gets the element at the front of the queue without removing. What the front position now? That is the peak. This is the peak. Front position is called the peak. Right now, which element is going to be deleted? So we will see the front. DQ is basically removing the element, and front is only telling you the position. It's not removing the element. And then two more operations we will see: overflow and underflow. When your queue is full, then we can say it is overflow condition, and when your queue is empty, then you can say it is underflow condition. Okay? So basically these are the simple operation we are going to do. We are going to do the implementation with the Python code. So there are the different ways how can you implement queue program. You can do the queue program with the help of list. If I talk about the Python, I can do the queue program with the help of list. I can do the queue program with the help of collection DQ. Okay? And I can write the program in the form of like classes also. Okay? So there are the different ways I can write the queue program. Okay? Real-time examples you already know. I have told you some basic features, like we will go through this. Like stack queue is also an ordered list of similar data types. Queue follows first in first out principle to perform the insertion operation on the queue called Enqueue, and similarly the DQ. The number of elements that a queue can accommodate is known as length. This is the similar, whatever we have studied in the stack, that is the same thing here. Number of elements is length. To perform the insertion and deletion, you must check the condition are, like if queue is empty, then condition is front and rear both are equal. And if queue is full, then condition is rear is equals to number of size. Okay, so these are the basic features. Now we will see the practical implementation. I'll open the Google Colab. Okay, you guys also do along with me. Okay, so now I'll write a simple program using the list. Only simple program, Python program, in which we will implement the queue with the help of list. Implement queue with list. Okay, this is the first one. Okay, here first I'll declare a empty list equals to empty. Okay, now what I will do, I'll enqueue some elements to this list. I'll add some elements. Okay, then I'll use the simple list function called append. Okay, all of you already know what is the append. Append 1, or I can give the value 100. And then I can print enqueue. Okay, and I can see output of enqueue is right now my list. Similarly, I'll append some more elements to this list. I can print this. And you can see there would be one element in the list. Okay, it's running. Simple, I have one element 100 in my list. Now I'll add some more elements. Okay, so similar thing I'll do, I'll append more elements, list dot append. In place of 100 I can write here 200, and then I can print simply enqueue my list. Okay, and similarly I'll append one more element. Okay, list dot append, and now I'm appending 300, and then print enqueue. Okay, and list. Now I have a list that having 3 elements. Okay, enqueue operation I have done. Now I'll do the dequeue operation. So for the dequeue, okay, I have run this 2 times. Okay, that's why now my list having 5 elements. I have executed this code one more time. That's why it's doing like this. Okay, so now what I need to do, I need to pop the element, and you know which one I need to pop? First in, whatever the inserted first, I need to out the first. So here I'll write list dot pop. I don't write only the pop. Inside the pop I'll pass index 0, and then you can see which one is removed. 100 is removed. Okay, you can print the list now. Now this is like this. Okay, similarly I can pop out other elements also, like list dot pop 0. Okay, and again I can print list. This time first 100, then one time 200, and now 300. Okay, if I'll run this one more time, then it will, and then one more time it will go on, and one more time. Now list is empty, and if I'll try to remove one more time, then what happens? Out of index. Okay, so here you can see I have just implemented 2 operations, enqueue and dequeue, and very simply with the help of list. Okay, same thing I can do, like I can also get the peak, I can also get the length. Okay, so here again I'll run this code. Okay, and now I'll get the peak. Print peak. What is the peak? Peak is the, You can get the front element as well as you can get the rear element. So here for the front I can write here 0 and for the rear I can write here -1. So for the last one I can write -1 and for the first one I can write the 0. Okay, there is one more way. This is the simple using the append function. Okay, in place of append function I can use here insert function also. How can I use the insert function? Like list, I'm taking empty list. Okay, and then I'm inserting element always at 0th index. So list dot insert and here 0, 100, 0, 10. Okay, and then I'll print list and I'll insert 2 more elements. List dot insert, always I'll insert at 0th index. Okay, print list. Similarly, I'll insert one more element, 0, 30. And then I'll print list. What happens here, first element, 10th element is inserted at 0th index. Then again I'm inserting second element 20 at 0th index. Then what happened? 10 is shifted to first position. So 20 at 0th index. Then 30 at 0th index. Now what I can do, I can pop directly. Like list dot pop. What it will pop? It's pop first element which I have inserted. And I can print list. This is the another way using the insert function. Like initially 10, then 10, 20, 10, 20, 30 and then we have removed 10 which is first inserted. Okay, so simple way we have implemented the queue using the list, using only the simple 2 functions, insert or pop, or either you can use append or pop. Same thing, now what I will do, I'll do the implementation of queue with the help of collection DQ. Because you know for the list we are using just kind of arrays, dynamic arrays, and you know there are the certain limitation of the dynamic arrays. We already know limitation of dynamic array. I have told you so many times, because when we want to insert some element that is beyond its capacity, then we need to shift all the elements. Okay, now we will do using DQ collection. We will implement queue with the help of DQ collection. Okay, so for the DQ collection, what I need to write here? From, just wait guys a minute. Just a minute, I am coming. Okay, sorry guys. So I'm back. Actually, using collection, I'll write the program for the queue. So okay, from collections import DQ. Okay, it's more memory efficient, you know that. We have used in the case of stack also. So here I'm declaring q equals to DQ function. I'm using this DQ function. With the help of this DQ function, I'm declaring a queue. Now we have in this collection, we have a function called the append left. If you search out over the Google, you can see about this collection. There are the certain functions. Documentation of this. Yes. It's not documentation actually. Yes, this one, Python documentation. And here you can see we have certain functions. So this DQ is a package, and inside this DQ package we have one function called append left. Yes, append left, what it will do, it will append the element left side. So we will use this function here. Okay, so q dot append left, and here I'm writing a value like 100, and then I'm again appending one more element, that is also I'm going to append left side. Okay, and then q dot append left 300. Okay, and then I'll print q, and you can see the output. Okay, it's running, and you can see the output is here 300. Initially I have inserted 100 and then 200 at the left side of this 100. Okay, and 300 at the left side of this 200. So whatever element I'm inserting is going to left side. And now what I will do, I'll pop out element one by one for DQ operation. And which one should be first pop out? 100. So I'll simply write a function q dot pop. You know that? Print q. Okay, 100 is removed. Similarly, I'll write q dot pop, and then I'll print q. Okay, and one more time I'll write this thing. And now my queue is empty. Okay, clear? How we can implement the queue with the help of list as well as with the help of DQ collection. Guys, can you give me a quick confirmation? Are you getting the things? We have seen what is the queue and different real-time scenarios of the queue, and then different operations in the queue, and now we are doing the implementation of queue. Okay? So the next thing is, same thing I can write with the help of class also. Like always I'm used to write the programs in the form of classes, because when you are going to do some complex question, when you are going to solve complex question, you have to do with the help of class. So now I'll write a class. How we can write a class for implementation of queue, I'm just going to write here. Okay. So here we will define a class. So I can say implement queue class using collection.dq. Okay, we will write a simple class from collections import dq. Okay, and then here class q, I'm taking a class q. Okay, and inside this class I'm just going to write certain functions for the q, dq, empty and full. and I'll also check out the size. All these functions I'm going to write inside this. So first of all, I need to define a constructor init, okay, and inside this I need to pass self, okay. Self dot, I can take a queue, okay. Self dot queue, a variable name I'm taking queue, and here I'm initializing a queue with the help of DQ function. This will initialize my queue. Now I'll define Enqueue operation, okay. Enqueue operation, I can write like this: self and data. Okay, I need to add this data. So what I'll use here, self dot queue. You can write in complex way also, but I'm writing using the simple functions. Okay, queue dot append. Here I'll use append left. Okay, append left. And then here I'm appending the value data. Okay. Similarly, I'll write one more function for the DQ operation. Def DQ. Okay. And DQ is, I don't need to pass any data. So here I'm writing only the self. And then self dot Q dot, I'll write directly pop. This is the DQ operation. Similarly, I'll write one function to checking either my queue is empty or not. So def is underscore empty, and then inside this I'm passing self, and here what I will return, length of queue, return length self dot queue equals to 0. If it is equals to 0, then it will return true, otherwise it will return false. Okay, and one more function I'll define here to getting the size. Okay, size self, and then I can write return length of self dot queue. Okay, these are the some important functions I have to write. Now I call those functions. So I'll create an object. Okay, here object I'm taking PQ. PQ equals to, what is my class name? Class name is Q. This one. I need to write this. PQ equals to this class name. And this will initialize my queue. Okay, and now I'll call Enqueue function or DQ function or size or empty. Whatever the functions I have defined, I can call. Okay. Vanshika is asking, ma'am, from where we get PDF notes of this class? You don't need the PDF notes of this class. You can get in the description of this video. You can get link of our website post, and you can read out that anytime whenever you want. You don't need the PDF. Why you need the PDF? Now everything is going online. Why we are collecting the data? Just save the link and you can read it whenever you need it. Okay. Yeah, seek I have not written. Seek I can write the front. We are generally taking the front for the seek. Okay, or I was just telling you about the seek. You can take it's up to you what you want to get. Generally we are taking seek is basically position of your front. Okay, which element is going to be delete. Okay, so let me write here what we were doing. Okay, I have defined a object of this function. Okay, PQ equals to Q, and now I'll call certain functions like Enqueue and DQ. So first I'll call Enqueue. Okay, Enqueue, and then here I'm putting 100. Okay, you can print this simply. Like here I have not written any function for the print. Okay, you can simply print, otherwise like here I need to write one more function. Okay, so I don't need it. I'll simply writing Enqueue and then PQ dot Enqueue 200. Otherwise I'll write one more function, just wait. And then I'm adding some more values like PQ dot Enqueue. Okay, and here I'm putting 300. Otherwise I can call here print self dot queue. Okay, now I'll call it. I have printed in this function only in Enqueue. So whenever I'm adding some data, it will add the data and then it will print the queue. Okay, otherwise I need to write one more function and then I have to call that function. I can write one more function like def print queue. Okay, and here self, and then I need to print this self dot queue. Okay, and after this I'll call PQ dot print underscore queue. And now this is my queue. Okay, I can get the size of the queue. How can I get the size? PQ dot, I can call the size function. Okay, PQ dot size, I have to print this because it will return some value and I'll pass this value to print. Now you can see the size of queue is 3. Okay, similarly print PQ dot, now I'll call DQ function. Okay, DQ, and now you can see the output of DQ. What happened? Why it is none? DQ, let me check it out. Self.queue.pop, it should be okay. Return. Pop, I'll return it now. Return this. Okay, now you can see this is my queue, size is 3, and which element I'm popping out? The first which I have enqueued, 100. So 100 first I'll DQ. Then I'll DQ another element. Okay, and now I can print PQ dot print underscore queue. Okay, so at the last my queue having only one value, that is the 300. I can call one more time either DQ, so it will be empty. Okay guys, so we have seen the implementation of queue with the help of list, with the help of collection, DQ, and we have written one program using class also. Clear till now, guys? Can you give me a quick confirmation? And you can hit the like button. Okay? This is the simple way to implement a queue. And there are some other ways we can implement a queue. We can represent a queue with the help of a stack. With the help of a stack, or with the help of linked list, with the help of array. Okay, so what we will do next, we have seen the simple queue, real-time operations, basic features, and then operations on queue. This program we have written, Python program using list, okay, and then using collection DQ. Okay, Ansari Mohammed Ali is asking a question, ma'am, is underscore empty condition is not in DQ. Is empty condition is when we are basically like, when you can check it out, like I have not checked it, either you can check it out, either my list is empty, then like when we are doing DQ, then we can write here one more condition. Okay, yeah, we can write in the DQ. I have just written simply here, you can give a condition like if self dot is underscore empty. I have not taken care all the conditions, right? Okay, this function, then what we will do, we will return false, or you can say want possible DQ, else okay, else we will return, we will pop out a element. Okay, so if it is empty, then we can, what happened, indentation, return q.pop. Okay, let me correct it. Now it's perfect. Now if I'll DQ again, okay, and one more time I'll DQ, then it will give you the false, nothing it will do, false. Okay, or either in place of false you can print any message like my queue is empty now. Okay, now come to the next thing, like we can represent this queue with the help of array or linked list. So representation of queue you can do by using two ways, using an array and using a linked list. We have seen with the help of array, but array have certain limitations. Okay, and like representation of a queue using an array, you can see here certain conditions we need to take care. Like here I have not taken care some conditions, I have just implemented the simply using only the positive condition, but sometimes it's underflow, sometimes it's overflow, so these things we need to take care. Somebody is asking certain real-time application of linked list also. Actually linked list we can use in case of like some applications of queue and a stack, like we can implement the queue with the help of linked list also. That would be better than the array part. So it depends on, we will compare the time complexity, and then you can see like in some cases when we just want to search element, then we will we just want to insert element, then we will go to the linked list. Okay, And linked list can be used to implement a stack and can be used to implement a queue also. Okay. Now come to the next thing. How we can do the implementation with the help of linked list. Now you know the linked list. All of you already know, already we have studied, we have done lots of example of linked list. Okay. First, just check it out. This we will go through this. We have done this array part. Okay, representation of quick revision we will do with this. Representation of queue using an array. Okay, so one dimension array can be used to represent a queue. With the representation of this, 2 pointers we need, front and rear. Okay, and what conditions we need to check it out? Queue is empty, then our front and rear both having position 0. And if our queue is full, there in case of array we have a fixed size. So if our queue is full, then what we will check? Our rear is equals to total number of elements and front is our 1. Okay, and queue contains elements which are greater than 1. Then you can say always rear is greater than the front. And total number of elements you can get it out with the help of rear minus front plus 1. These are the theoretical part. Practically you have seen how we can manage the front and rear. Simple, using the simple function you can manage the front and rear. But if somebody asking you for the how you can manage the front and rear, then you can tell these concepts. Insertion, Enqueue operation. How we can do the insertion? So this is the simple algorithm. For the insertion, we will check the either queue is full. We need to check out this condition. And if our queue is empty. Okay. For the deletion or dequeue, what we will check out, if our queue is empty, then we don't delete. Otherwise, we will delete. We will follow certain steps. That part we have done. Now come to the representation of queue using a linked list. Okay, a doubly linked list. You have implemented a doubly linked list which allows us to move in the both ways. We can use the doubly linked list. Here we need to check out two states like queue is empty and queue contains at least one element. We can write the program for this also. Okay, just wait. Or either you guys can write by yourself also this program, representation of queue using the linked list. Like what we need to write in the form of nodes, next, or whatever your head. Okay. Now I can tell you the different applications of queue. Like we have seen some real-time scenario, but you can also see some more applications of queue. What are the real-time applications? Like serving request on a single shared resource like printer, CPU scheduling and disk scheduling. When I'll complete this queue part, I'll show you the complexity of all 4 like array, linked list, queue and stack, and in what cases which one is better. Okay, so just wait for that. Serving request on the shared resource like printer, CPU scheduling, like whenever you are studying operating system subject, in that sometimes happens there is a deadlock and now my now my interrupt is not here. So that thing, how CPU is managing the scheduling, how disk is managing the scheduling, all these things can be done with the help of a queue. In the real life also, whenever you are going somewhere, this is a queue, we are in a queue. Like when you are calling to some customer support and they are telling you are at the queue number 5, you are at the queue number 6. Okay, so there are already certain customers available. So they need to satisfy first their queries. And queue are used when data is transferred asynchronously. Data not necessarily received at the same rate as sent. So that time we need to maintain a queue. If there is enough staff to solve the queries of their customers, then there would be no queue. But when we have less staff, means our request is not served as soon as it is generated. That time we need a queue. Okay? A difference with the stack, in the stack we have last in, first out. Stack has some certain differences with the queue. In the stack, we have only one end for the insertion and deletion. We have only one end. But in the case of queue, we have two ends. For the insertion, we have separate end, and for the deletion, we have separate end. What happens if you will use the stack in the case of customer service? Then the person who is coming at the last will get the service. The person who came first never get the service. Okay? And simply, breadth first search uses a queue data structure to find the element from a graph. Like after the linear data structure completion, we will go to the non-linear data structure, and graph is one of the non-linear data structure. Okay, so that time also we will see how graph works. So BFS is basically uses the queue. And queue are used as buffers in most of the applications like MP3 media player, and you are making certain playlist. So it always works like a queue. Ankit is asking, ma'am, I have a request to add. Please attach the topic you taught that day with the class title. Okay. Okay, Ankit, we will take care of this also. Like before the class you want. Okay, we will write that. And it is used in the operating system for handling the interrupts. Okay. So these are the certain applications of the queue. Now we will see different type of queue. And yesterday I have given you one question. Have you done that? Postfix evaluation using the stack. Guys, can you please give me confirmation in the chat window who has completed the question? Implementation in the Python for the postfix expression evaluation using the stack. And day before that, I also have given one more task, that is the stock span problem. You have to solve that also. Just do the assignments along with me so that you will get the more practical knowledge. It's not like your college professor class, like you are studying only the theoretical part and you have to do the implementation by yourself. Here I'm telling you certain implementation, most of the part I'm telling you, but what you need to do, you need to practice after the class. Okay, and it would be good for you. Now come to the various types of queue structure. Like two things, different representation we know, and there are different type of queues. We have circular queue, we have double-ended queue, or we can call it DQ, and we have priority queue. Okay, so now we will see these three type of queue, basic introduction of these three type of queue. Okay, let me open this. First is you can pick double-ended queue and you can call it DQ also. What is the double-ended queue or a DQ? Okay. So basically DQ is a special kind of queue. Here what happens, at the both end we can do the both operations. Like at the rear end we can do the insertion deletion, and at the front end also we can do insertion and deletion both. Okay, so you can say DQ stands for double-ended queue. Like this double-ended queue we also call it DQ. Generally we call it DQ. So DQ is double-ended queue, and in simple queue, insertion takes place from one end while the deletion takes place from the another end. An end at which insertion occurs is called the rear, and deletion occurs will call the front end. We know that. Okay. Now what happens in this DQ? It is a linear data structure, simple to our normal queue, but both the things you can do with the front and both the things you can do with the rear. Okay. So you can say DQ can be used both as stack and queue. What happens in the stack? You can use the DQ in the form of stack also. And in the stack, what happens at the same end? We can do either insertion or deletion. Stack is LIFO, last in, first out. Okay? Therefore, we can say DQ can be considered just like a stack. And DQ also works like a queue also, because one end we can do the insertion and another end we can do the deletion. There are the two types of DQ. There are the certain restrictions over the DQ. One is the input restricted and another one is the output restricted. How can you define them? Input restricted as well as output restricted. If I talk about input restricted, it means input is restricted at one end. Some restrictions are applied for the insertion. So here insertion only takes place at one end. Okay, input restricted. Input is only at one end. What is the input? Input is insertion. Where we will do insertion? We will do insertion at rear end. So insertion is only takes place at rear end, as well as deletion is take place at both the end, front as well as rear. Got it? So you can say it is a DQ in which insertion allows only at one end, whereas deletion from the both end. This is input restricted DQ. Okay, input restricted queue, it is a part of DQ, double-ended queue. Now come to the second type, output restricted queue. Output restricted means output will be done at one place. You can say some restrictions are applied to the deletion. Output is restricted queue means deletion can be applied only from one end. Okay, whereas insertion is possible from both the ends. So here deletion only takes place from the front, and insertion you can do from both sides, front as well as from rear. Okay. Now come to the next. This is the simple DQ, and in the DQ also you can do the certain operations like insert at front, delete from end, insert at rear, delete from rear. Okay, we can perform these operations. We can write the program for this also. And generally this DQ we are going to implement with the help of circular array or with the help of doubly linked list. Okay, and this DQ can be used as a stack and queue because it performs both the operations at both the end. Okay, I'm not telling the implementation part. You guys just try it. Otherwise, I'll tell later. Okay, first we will understand what is the different type of queue. Okay, so one type we know that is a DQ. Now come to the another type of queue, that is the priority queue. Okay. Priority, what is the priority queue? In the priority queue, there are certain priorities attached with the queue elements. Like we have certain elements, it is not like it will be always deleted from the front end. What happens here, it basically having elements having some associated priority with them. Each element, like here we have certain elements 900, 850, 77, 764, something like these values we have. And we have one more extra thing is priority. So the element with the highest priority would come first in the priority queue. Priority means elements in which order they will be deleted. So here what happens, elements are either arranged in the ascending order or in the descending order. Because here priority queue supports basically for the comparison, you can say. Elements either stored in the increasing order or in the decreasing order. Okay. So the element who has highest priority, like this is arranged in the decreasing order, like first and third. Here, Enqueue is from the left side. So front is this. So it is in increasing order. So element which is first inserted having higher priority here, and it is the smallest value. You can say the element who value is smallest having the highest priority. So higher priority element is processed first. So this element should be processed first. It can be in the reverse order also. Like the 900 can be here. Like element can be either in a ascending order or in a descending order. Every element have some priority with it. Okay? And same operations we will do here. So you can say priority queue is basically two type of priority queue. One is the ascending order priority queue and another one is the descending order priority queue. Okay? So this is the ascending order priority queue. Like the element minimum value having highest priority. So this is the ascending order. Lower priority is given to the higher value. Okay, so smaller number having priority 1 and that is the highest priority. Similarly, we can have the reverse priority queue, that is the descending order priority queue. And in the descending order priority queue, what happens? A higher priority number is given the higher priority. Like we can have the values just reverse. And 900 is here and then 850, then 77 in the reverse order. And the value which is higher value of a numerical value, you can say, having highest priority. Okay? And implementation of this priority queue you can do with the help of linked list, either binary heap or binary search tree. Okay? So implementation of structure of this priority queue you can do with the help of circular array, multi-queue implementation, doubly linked list or heap tree. Okay, I'm not going to the implementation part now. Now I'll see the third type of queue, that is the circular queue. Okay, what is the circular queue? Basically, it is just like the normal queue, but the one difference is the last element is rounded with the attached with the first element. Like why we need the circular queue? Sometimes why we need the circular queue, like sometimes what happen when you are implementing a queue, okay, with the help of array, okay, and you know array have some fixed size. So what happens, sometimes in the starting position we don't have elements, like this is the starting position, this is the starting position, here we don't have element, here we don't have element, here we don't have element, and our elements are started from here until the end. This is my rear is last one and front is the first element. First element is at 20th position, then 30th, 40, 50 and 60 values, sorry. This is 0th position and like this. By default, our queue have 3 vacant spaces before this 20. 3 vacant spaces before this 20. Okay, so we have some vacant space are left in the beginning and we cannot utilize them. So overcome this limitation, we need a circular queue. In the circular queue, what happens, here rear is this one and front is this one. Okay, first elements comes the first after the last element. So here we can utilize these 3 spaces also. We can add more elements. Basically, last position is attached to the first position. And it makes a circle. And we can add 3 more elements. If our last location is full, if our queue is full, then coming element will be inserted at this first position. I can draw this, let me draw here. Okay, and circular queue can be like this. My drawing is not good. Okay. And here you can say some position like 0 and then 1, 2, 3, 4 and 5 and 6. Okay. And what happens, you have some elements here. Okay. You have some elements started from, like here you have value 10, here you have 20, 30, 40 and 50. If it is a linear queue, okay, what happens here, we have some value at location this 50, 40, 30, 20 and 10. And here is my rear end and here is my front end. If one more element I just want to insert, then what it will say, my queue will say queue is full. New element, and then you can say queue is full. But still I have 2 locations. So what we will do in the circular, we will join this with the last location, like this first position with the last position. So whenever new element comes, we will insert that element here. So we can utilize these empty vacant spaces at the beginning. That's the concept of circular queue. Okay? Guys, got it? Different type of queue we have seen. What are the different type of queue? We have 4 type of queue. 3 type of queue: doubly, double-ended, queue, or we call it DQ. Second is priority queue. And third is circular queue. Okay? These are the three types of queue we use. Now I can tell you one implementation, like I can write a program for the queue implementation using linked list. And for rest of the queue, you can try by yourself. Okay? Agree, guys? You can ask me any question till now if you have. Like I have told you so many things. We have seen what is the queue, applications of queue, implementation of queue, types of queue. Okay? Now I'll write a program, queue implementation with the help of linked list. Okay? Let me write it. And you guys will help me. Okay? You know that. Most of the things we already done. Okay? Queue implementation with linked list. Okay? Now here I'll write a class. Class node. Okay? What we used to do in the linked list, we used to write a class node, and in this class we will define our nodes. Okay? So def init, and this constructor I'll define self, and I can write my data. Okay? And I can write a next also. Okay, and next I'm taking none initially. So here I'll write self.data equals to data, and similarly self.next equals to initially none. This will create a node of linked list. Okay? We are creating nodes for the linked list using this class. Now I'll define one more class for the queue class. Okay? Class queue. And inside this queue class, I'll define constructor for defining the queue. Okay, def init underscore, and then I'm passing self. Here I can use the DQ collection, or simply I'm writing using the another way, like I'm going to use the concept of front and rear. Okay, so self. There are the different ways to write a particular program. Okay, self.front, I'm taking self.front equals to none initially, and similarly I'll take self.rear also equals to none. Now I'll write certain operations, enqueue, DQ. Before that I need to check it out empty. Okay, def is underscore empty self, and then here I'll return. When I can say empty, my front is none. Okay, so I can write self.front equals none. Okay, Now I'll write a function for the enqueue. I'll directly write def enqueue. Okay, and I'm calling here self comma data. Okay, now I need to create a node first and then I need to add the elements. Okay, now we will write enqueue function. Inside the enqueue, what I need to write? I need to create a node. Okay, so ITR, I'm taking a iterator, or you can take a simple temp variable. Temp equals to node, and inside the bracket I need to pass data. It will create a node, and then I'll check certain conditions where I need to insert. Okay, if self dot rear equals to none. Okay, then I'll insert element, and first element would be inserted this self dot friend equals to self dot rear one element equals to this temp element, and we will return. Okay, otherwise what we will do, we will see one next also. Okay, so self dot rear dot next equals to this temp, and self dot rear equals to temp, because we need to take next also in a linked list. And similarly we will write a method for the dequeue also. Def dequeue. Okay, and for dequeue I don't need to pass any data. It will remove the first element which we have inserted. So what we will do here, we will check a condition for if it is empty. So self dot is underscore empty. Okay, if it is empty, then we can say we can return nothing. Sorry, I can return. Okay, else what I will do, I'll write here temp equals to self dot friend, because I'll remove from the friend. Okay, and then I'll set new friend, self dot friend equals to temp dot next. Okay, and if my friend is none, if self dot friend equals to none, then I can set rear also none. Self dot rear equals to none. Okay, this is the thing I need to write. Now I'll create a object of this queue class. Okay, I'll create an object of this queue class. Two functions I have defined, enqueue and dequeue. Queue equals to queue. Okay, and then I'm writing here queue dot enqueue. And here I need to pass certain values, like 100 I'm passing. Okay, and print I can do, otherwise I can directly print the values, front or data. Okay, and then I'll add more values. Like I'll enqueue 3 more values. 100 and then 200 and then 300. Okay. Now I'll dequeue. Queue dot dequeue. Okay. Now I'll run this code. Hopefully it will work. But I have not printed. I'll print this dequeue part. Inside print, I'll pass it. Okay. None. dequeue, I have not returned anything. Okay. For the printing part, I need to write something else. Some more functions. But it will work like this. We need to check it out certain conditions for the enqueue and dequeue. Yes, I'll need to write the print function also. Okay. So this is the basic way how you can implement the queue with the help of linked list. Okay. So you guys can try all these things. Now we will see the comparison of complexities. Okay. We will see comparison of complexities, how linked list works, how array works, and how queue works, and how stack works. Okay. So I can tell you one site, Big O cheat sheets. Big O cheat sheet. bigocheatsheet.com. Here you can see the comparison of site. Yeah, this one I need. We will include to our notes also, but still right now it's not included. That's why I'm telling you this. bigocheatsheet.com. You can see here, like what we have seen till now. We have seen array. Like array we have seen a stack, we have seen queue and singly linked list and doubly linked list. Most of the things from these 5 we have seen. And now you can do the comparison, like for accessing element. You can see for accessing element in the array you can do the random access order of 1. For searching an element in the array it will take order of n. For insertion, it will take order of n because we need to sift all the elements. For deletion also, we need to take order of n. Okay. So if I talk, this is the average case. Generally, we talk about the worst case. So this one is for worst case. Worst case array only for the access array having only order of 1. So green color means this is the best for accessing the elements. So array is best for the accessing the elements. Now I'll talk about the stack. Stack is for accessing the element, it will take the order of n. For searching also order of n, but for insertion and deletion it's take order of 1. Why? Because at the one end we are doing both the work. So either you can insert and delete any element at any time, it will take order of 1. Same thing for the queue, insertion and deletion will take the order of 1, but the search and access will take order of n. Singly linked list also the same way. For the linked list, we have to traverse. For the searching or for the accessing, we have to traverse the elements. Okay? So these are the complexities of these 5 data structures we have studied. Or you can say, in short, 4 data structure, linear data structure. Guys, I have written lots of code. You guys can print the queue. So many program I told you. You can just try this one. And somebody who have written the print function, please paste the code here so the other people get the help. Simple, you need to write 2 lines of code. Okay? So these are the complexities for the accessing, searching, insertion and deletion we need to take care. And binary search also we have done. Yes? Binary search we have done. So for the binary search also, for searching, for accessing the element we have, this is binary search tree. This is not binary search. Okay? Further we will see shortings, we will see tree, we will see graph. These things are remaining. Okay? So I think this is enough. And just revise after the class linear data structures. Okay? Then we will go ahead towards non-linear data structures. And that are going to be more interesting. And like, if you should first the basics of linear data structures. And practice more and more questions over these data structures. Okay? So thank you so much, guys. And I think this is enough for today. We'll see you tomorrow. And don't forget to complete your assignments after the class. Complete your assignments, like complete your attendance formalities, and whatever the question I'm providing in the class, you have to do that. Okay? Thank you so much. I'm just going to end.